Today we will discuss the topic hygroscopy. Now, what is hygroscopy? Hygroscopy is a phenomena which is shown by certain hygroscopic substances. In this, these hygroscopic substances absorb moisture from the atmosphere, but they do not dissolve in this absorbed moisture. Children, you must remember that the same type of phenomena you have learned in deliquescency also. But in deliquescency or in deliquescent substances, we have learned that the deliquescent substances absorb moisture from the atmosphere and forms a saturated solution. That means they dissolve by themselves as soon as they are exposed to the atmosphere because they absorb moisture. So now what is the difference between the hygroscopic and deliquescent substances? There is one basic difference, which is that deliquescent substances forms a saturated solution as soon as they are exposed to the atmosphere, but hygroscopic substances do not form any kind of solution. That means they do not dissolve although they absorb moisture from the atmosphere. Now these hygroscopic substances can be both, they can be amorphous as well as they are liquid in nature. For example, a solid amorphous hygroscopic substance is calcium oxide. Calcium oxide is the quicklime. Then the liquid is your sulfuric acid. So calcium oxide, the common name for the calcium oxide is quicklime. This is the first type of hygroscopic substance. Then there are calcium chloride infused state. This is also a kind of hygroscopic substance, but the most important hygroscopic substance that we must keep in mind is concentrated sulfuric acid. Here, please do keep in mind that the sulfuric acid is hygroscopic when it is concentrated in nature. The dilute sulfuric acid does not act as a hygroscopic substance. What is the relevance of hygroscopy? The hygroscopic substance behave as the drying or desiccating agent and also as the dehydrating agent. Now the question is, what is drying or desiccating agent and what is a dehydrating agent? Sometimes we have got gases which are moist in nature, and what we need to have is, for the reaction, gases in the pure dried state. That means if the gas is moist, then a moist gas cannot be used in the reaction. So how to dry a moist gas? How to dry a moist gas? कैसे dry करेंगे? We will simply pass this moist gas from this drying or desiccating agent. क्या करेंगे? एक वुल्स बॉटल लेंगे और इस वुल्स बॉटल में गैस को पास करेंगे. कौन सी गैस को? मॉइस्ट गैस को. मॉइस्ट गैस, राइट? और इस वुल्स बॉटल में we will fill it with concentrated sulfuric acid, right? The concentrated sulfuric acid is the desiccating or the drying agent. So what will happen when the moist gas is passed through this concentrated sulfuric acid? After that, after passing it through this, the concentrated sulfuric acid will absorb all the moisture, and after absorbing the moisture, obviously it's a gas, so it will liberate, and whatever gas is given out, that will be your dry gas. So can you see the difference? It's the moist gas and the liberated gas is dry. Simply what has been done, that the gas has been passed through the concentrated sulfuric acid, and here the concentrated sulfuric acid is acting as a drying and a desiccating agent. Which property of concentrated sulfuric acid is making it as a drying agent? That is the hygroscopy of the concentrated sulfuric acid. Now what is dehydrating agent? Dehydrating agent works same. Dehydrating agent also absorbs the moisture from any moist gas, but here is one difference between drying and a dehydrating agent. What is the difference? That a drying or a desiccating agent removes the water which is physically combined. The water which is physically combined with the gas. That means this water is not a part of the gas. The water is only physically combined. It is not a part of the molecule of the gas. So obviously it can be removed. However, dehydrating agent is the one that is able to remove a chemically combined water. How? Let's have an example. CuSO4.5H2O. Right? Now this is a hydrated salt. You all know what is water of crystallization. So this is water of crystallization, and this water of crystallization is attached with the copper sulfate chemically, right? So simply by adding the dehydrating agent, which can be concentrated sulfuric acid, if this is added to copper sulfate .5H2O, what will we observe? That this water molecule will be lost and only CuSO4 will be obtained. That means the chemically combined water has been removed. Therefore, it gives us one more conclusion, that is that whenever a drying or a desiccating agent is being used, this is a physical change. Whereas here, since the chemically combined water has been removed by the dehydrating agent, it is showing a chemical change. So all this is happening because of one property of the substance used here, that is concentrated sulfuric acid, is hygroscopy. Since concentrated H2SO4 is hygroscopic in nature, that is why we are using it as dehydrating and the drying agent both. The next topic is hard water and soft water. Now what is a hard and a soft water? The definition will be more clear when we will read it in terms of soap. The simple definition: if the water with the soap produces froth, right? If it produces froth with the soap, then the water is soft. But if no froth is produced, then the water is hard in nature. Okay, So hard water is defined as the one that does not produce froth or lather with the soap, and if the water is producing lather or froth with the soap, then we call it as the soft water. Now, what is it that makes water hard or soft? That is the presence of certain salts in it. Which salts make water hard or soft? If the water is soft, then it is not a problem. But if the water is hard, then it is because of the presence of certain bicarbonates, chlorides, and sulfates of calcium and magnesium. So if we have the bicarbonates, chlorides and sulfates of calcium and magnesium, then their presence makes the water hard. That means in that case no lather or froth is formed when the water is used with the soap. Now again, the hard water is of two types. The number one is temporary hard water, and the other one is a permanent hard water. Now, what do you mean by temporary hard water or permanent hard water? That means that a water that whose hardness can be removed using simple methods, that we call as temporary hard water. But the type of water in which we'll have to make it undergo certain chemical treatment, such a water will be considered as the permanent hard water. Now, out of all these impurities, only the bicarbonates of calcium and magnesium are present in the temporary hard water. So basically we can say calcium bicarbonate, magnesium bicarbonate, these both are responsible, the presence of these type of salts are responsible for the temporary hardness of the water. But the presence of chlorides and sulfates of calcium and magnesium, that is MgCl2 and CaCl2, also MgSO4 and CaSO4. These four types of salts are responsible for the permanent hardness of the water. So we must keep it in mind that although all these three salts of calcium and magnesium are present in hard water, but again, since they are of two types, temporary and hard, so permanent, so temporary consists of only the bicarbonates, whereas the permanent hard water has got the chlorides and sulfates of calcium and magnesium. Since different type of salts are present in temporary and permanent hard water, so in order to remove them, obviously different methods are applied. So what are the different methods by which these hardness can be removed? So that is removal of hardness. Alright. For the temporary hardness of water, the method that is applied is simple boiling. When the temporary hard water is boiled, the bicarbonates of calcium and magnesium can be removed. How will they be removed? Let's have a look. CaHCO3 whole twice. When it is boiled, correct? we will obtain CaCO3 plus H2O plus CO2. अब यहाँ एक कंफ्यूजन दिमाग में नहीं आना चाहिए that we are boiling CaHCO3 whole twice. No, we are not boiling CaHCO3 whole twice. Imagine karo that you have got water which is temporary hard water. ठीक है, we are boiling this temporary hard water. हम एक्चुअली में किसको बॉईल कर रहे हैं? हम इस टेम्परेरी हार्ड वाटर को बॉईल कर रहे हैं. दिस इज गेटिंग बॉइल्ड. करेक्ट. नाउ ऑब्वियसली सिंस दिस इज टेम्परेरी हार्ड वाटर, इट is having bicarbonates of calcium and bicarbonates of magnesium. So this boiling has an effect only on the calcium bicarbonate which is present here in the water. So what will happen? This calcium carbonate will settle down as the precipitate. The carbon dioxide will liberate as the gas, and obviously this product water will be added to whatever the water is left behind. You can simply filter this water and you can simply remove the calcium carbonate that has settled down after the boiling. The same kind of reaction is observed when on the magnesium bicarbonate as well, that is MgHCO3 whole twice. On boiling, it will produce magnesium carbonate plus water plus CO2. Correct? And this will also, the magnesium carbonate will settle down and carbon dioxide will be released, and after that what is left? Only the water that will be added in this water only. So whenever we are talking of boiling, think that we are boiling about the water. No confusion should be there from where did we get this calcium or magnesium bicarbonate. It was present in your temporary hard water sample. The second method for the removal of the temporary hardness of water is by treating it with washing soda. So the first method was boiling the temporary hard water, and the second method is by treating it with washing soda. Now what is washing soda? Washing soda is sodium carbonate. Okay, so when Na2CO3, that is the washing soda, is added to the temporary hard water, that is the water sample containing the calcium and magnesium bicarbonate, then what will happen? CaHCO3 whole twice, when treated with calcium carbonate, it will produce NaHCO3 plus CaCO3, right? Whereas with Na2CO3 plus MgHCO3 whole twice, it will also produce 2 NaHCO3 plus MgCO3. Now this calcium carbonate or magnesium carbonate, they both will settle down along with these bicarbonates produced, and thus the water can be filtered since all of them will settle down as the precipitate. So whatever the sample was taken the salts will be removed from it, and the water which will be filtered out will be obtained in the form of soft water. Alright, so in a nutshell we can say for the removal of the temporary hard water we can use two methods. Number one is boiling and number two is with the help of washing soda, and the precipitates formed can be filtered out and the sample obtained will be soft in nature. Now let us talk of the permanent hard water. The permanent hardness of the water can be removed only by one method. We are not taking boiling there because by boiling the permanent hardness cannot be removed. So permanent hardness can only be removed using the washing soda. So what will happen with the sample of water? The washing soda is again Ne2CO3, right? We have now taken the sample of hard water with permanent hardness. That means it has got all these salts, chlorides of calcium, magnesium and sulfates of calcium and magnesium. When the washing soda is added, what will happen? Let us take the example of magnesium chloride. What will happen to MgCl2? It will simply produce sodium chloride plus magnesium carbonate. Okay, and these salts will settle down as the precipitate and the water can be filtered. Similarly, what will happen if Na2CO3 is added? Then the other salt, calcium chloride, it will produce again NaCl plus CaCO3, correct? Again they will be obtained as the precipitate. These were regarding the chlorides of calcium and magnesium. Now let us see what will happen to the sulfates of calcium and magnesium. The same type of reaction will occur here also. The washing soda Na2CO3 plus, now the sulfates MgSO4, correct? And what will they produce? Sodium sulfate Na2SO4 plus MgCO3. Both will be obtained as the precipitate. That means they will settle down, they can be filtered. Similarly, now let us talk of calcium sulfate. What will happen with calcium sulfate here is Na2CO3 plus CaSO4 and it will give us sodium sulfate Na2SO4 plus CaCO3, which will again settle down as the precipitate. That means that if we have got a sample of hard water containing all these 1, 2, 3, 4 salts, here we have got these 4 salts, and when they are treated with the washing soda, right? Then what will happen? This washing soda is going to react with them and will produce the precipitate in the form of these salts. Fine? And these salts then further are precipitated, filtered out from the sample of water. Whatever is left behind, जो भी पीछे बचेगा filtration के बाद जो sample of water we will get, that is going to be soft water. And that is how the water can be converted to soft from the hard water. Both the permanent and the temporary hardness is thus removed. Now the advantages of using soft water and hard water. Since they both have got different types of properties, hence obviously their advantages are different. The soft water is good for the washing purpose as it forms lather with the soap, hence it is good for using for the washing purpose. The second is the soft water have a pleasant taste. In case of hard water, since the hard water contains the chlorides and sulfates of calcium, therefore it is a good source of calcium which is otherwise required by the human body for strong bones and teeth, and hence it is consumed for better and stronger growth of the bones and teeth in case of especially the children. The second is it has a taste, it has a kind of saline taste, and therefore it can be used in brewing. Brewing means in the preparation of alcoholic drinks like beer, etc. The third, it can also be used in tanneries, that is the leather industry. So that is for the advantage of hard and soft water. Now the disadvantages. The disadvantages of soft water and hard water. First of all, the disadvantages of the soft water. The soft water we know does not contain large amount of calcium ions, hence it does not help in strengthening of bones. Right? Because for the bones, calcium is one of the most important mineral that is required. Second, it can lead to lead poisoning as it dissolves the lead which is present in the water pipes. Generally, the water pipes, when are made, the lead is used for the making of the pipes, and this lead is easily soluble in the soft water. Hence, it can lead to the lead poisoning. The third one, the chief disadvantage, this is the most important disadvantage of the usage of soft water, that it causes the heart ailment and the coronary diseases. Why? Because this water does not contain the sufficient amount of minerals which are used or which are required for the strengthening of the body, and in the absence of these minerals, the heart ailments and the coronary diseases are caused. Then the disadvantages of the hard water. Number one, the hard water since do not form lather with the soap, therefore it is not used for the washing or the bathing purpose. Now, what is the outcome if the hard water is used despite the knowledge of not preferable for the washing and bathing purpose? If the soap is used with the hard water, then this soap reacts with the water and forms a white precipitate which we call as scum. Now this scum is a kind of a substance that clogs the water pipes, that sticks to the floor, that sticks in the hair. If you wash your hair with it, with the soap, then this scum is one of the biggest problem when the hard water is used for the washing or the bathing purpose. This also hardens the cloth. The fiber of the cloth gets destroyed, the texture of the hair get destroyed, and hence it is not preferred for the washing or the bathing purpose. Second is the calcium carbonate. This is the basic culprit here. The calcium carbonate which is present in the hard water forms the line scales inside the water pipes. जो पाइप होता है, कोई भी पाइप हो, वाटर पाइप हो या आपका स्टीमर हो या केटल हो, जहाँ पर भी you are using the hard water in order to produce some steam, or you are using it for heating purpose, then this calcium carbonate results in the formation of lime scales, and these lime scales clogs the pipes, उसको बंद कर देता है, hindering the flow of water. कई बार आपने देखा होगा जब हम गीजर वगैरह को वापस से उसको मेंटेन करते हैं, अपने गीजर को अंदर से क्लीन करते हैं, तो अंदर से बहुत छोटे छोटे व्हाइट कलर के नीडल शेप बहुत सारा कुछ crystals type substances निकलते हैं. They are your line scales which clogs even the functioning of the geyser. So calcium carbonate is basically responsible for that. And the last one is not suitable for preparing the solutions. क्यों? Because the solutions are to be used in the chemistry lab, and hence these solutions must be pure in nature. Then only they will give the true results. Otherwise, the results given out by the solutions which already have the certain minerals which are not required, obviously the result given will be false in nature. So today we have discussed the advantages and disadvantages of soft and hard water, the definition of soft and hard water. We also discussed about hygroscopy and the difference between hygroscopic and deliquescent substance. I hope today's lecture is clear to all of you. So thank you for the day.